Hello everyone. Let's begin with a little puzzle. When you push a toy car, it rolls forward. But the moment you stop pushing, what happens? Yes, it slows down and eventually stops. Now that makes us think, do objects always need a force to keep moving? This question may sound simple, but the correct answer came only in the 17th century with Galileo. And that discovery opened the door to Newton's laws of motion, the very foundation of modern physics. But centuries before Galileo, another great thinker had given his answer. Aristotle. Aristotle, the Greek philosopher from the 4th century BC, had a very influential idea. He believed that if a body is in motion, then some external force must always act to keep it moving. For example, he thought an arrow continues to fly because the air behind it keeps pushing it forward. So, in his words, motion cannot sustain itself. His conclusion became known as the Aristotelian law of motion. An external force is required to keep a body in motion. Now, at first glance, this sounds perfectly reasonable, right? Look around in daily life. If you stop pedaling a bicycle, it slows down. If a child pulls a toy car with a string and then lets go, the car comes to rest. From our everyday experience, it really feels as though continuous effort is necessary to maintain motion. And that's why Aristotle's view was accepted for nearly 2000 years. But let's think carefully, is that really the case? The flaw lies in ignoring one hidden enemy, friction. Take the toy car example. The child must keep pulling because the floor applies an opposing force, friction. If the child applies a force equal to this friction, the car keeps moving. The moment the string is released, friction alone acts and the car comes to rest. Now imagine a world without friction. The car, once set in motion, would continue rolling forever without any further pull. So Aristotle's mistake was not realizing that resistive forces like friction and air drag are what bring bodies to rest. So, do we ever need forces to keep bodies moving? The answer is yes, but only to overcome resistive forces like friction in solids or viscous drag in fluids. In the natural world, these resistances are always present. That's why we often feel as though motion requires continuous effort. But the deeper truth, revealed by Galileo and later Newton, is this: in the absence of resistance, no continuous force is required for uniform motion. This insight became the first step toward Newton's first law of motion, the law of inertia. Let's make this idea concrete with an example. Imagine a car of mass 1000 kilograms moving at 10 meters per second on a perfectly frictionless road. Once the car is in motion, suppose the engine is switched off, no driving force at all. Now, what is the net force on the car? Since friction is zero and applied force is also zero, the net force is zero. By Newton's first law, a body with zero net force continues its state of motion. That means the car will keep moving forever at the same velocity of 10 meters per second. Amazing, isn't it? The only reason real cars stop is because of resistive forces, not because motion demands continuous effort. Let's quickly summarize what we've learned. Aristotle believed that motion requires a continuous external force. This seems true from everyday life but is actually false because he overlooked resistive forces like friction. The correct understanding is that external forces are needed only to overcome resistance, not to sustain uniform motion. And this realization, thanks to Galileo and later Newton, led to the formulation of the laws of motion that govern everything, from a rolling ball to a spaceship gliding in outer space. I hope you now have a clear sense of why Aristotle's view was called a fallacy and how it helped spark the birth of modern mechanics. See you in the next session, where we'll unfold Newton's first law, the law of inertia, and discover why bodies resist changes in their motion.